Hello everyone. In this video, I'm going to talk about logging in Python. Throughout the entire series, I've displayed all of the output using the print statement. And that's not going to change because in this situation, that's the easiest way to demonstrate the code. However, you will soon one day find yourself building a program where the print function is simply not enough. Your program could have a lot of different classes and functions, or maybe it's just processing a lot of data. It could be both. In this case, all of the information you're printing out will eventually be lost to your command line's buffer. And even though you could increase this buffer, there will be a point where doing so will have consequences on your machine's performance. There's also situations where printing to the console screen is not even very useful, like GUI applications, especially games, because the user will want to focus on the GUI part of the application 100% of the time. So while all the information the user needs to run the application is displayed on the GUI, all the system info, errors, debugging, and etc. can be recorded through logging. And what makes logging useful over printing is that in addition to printing everything on the screen, it could also send the information to a file. This will allow you to review all of the data later on if needed. For Python, there is a logging module included in the main library, and it provides functionality right out of the box by printing messages to the screen, as you can see here in this example. So all you have to do to start using logging is to import logging and then say logging dot whatever level you want to use, whether you want it to be a debug message, an info message, a warning, an error, or even something critical. However, as you will soon see when I run this, by default out of the box, both debug and info messages do not show up on the screen. The reason behind this is a mechanism called logging level. There are 5 standard logging levels: debug, info, warning, error, and critical. And as the severity of these levels increases in this order, so does the numerical level of each of these logging levels. The logging will only log messages with the minimum log level we set it to. Out of the box, the level for Python logging is set to warning, so only info and debug messages will be ignored. But don't worry, because we have plenty of different ways to configure the logging to our needs, starting with the easiest one, the basicConfig function. So of course, we always start off by importing the logging module, and then once we import the module, I use the module to access the basicConfig function. And as you can see here in the linter help box, it's basically just a bunch of keywords that we use to set up the logging the way we want it. Right now I'm using 3 of the most common ones to just set up a basic stream logging, which is basically just still outputting stuff to this console screen. I don't actually know if encoding is actually needed for outputting to the console, but I did put it there just in case. This time, the level for our logging is going to be set to the lowest level so that we can capture all logging messages. And on top of that, I am modifying the format of the message in this call. And these are specific keywords that you can find in the Python logging documentation online. It will give you a whole list of keywords you can use to specify what you want in your format. And so for me to explain what this is doing here in the format string, I need to first explain what %s is. So basically, one of the different ways you can format a string with variables is by using percent representation. But basically, there's like %s, %f, %d, and I think there's a few others. But basically, you would create a string, put all the percent s's and d's or f's and whatever you want in there, and then at the end of that string, you add another percentile sign, and after that percentile sign, you will have a list of variables that you want inserted into that string, and they have to be in the same order that you want them to appear in that string. In this case here, because we have keywords in between the %s, what that's for is to access data that's in a map or a dictionary. This format string is going to be inserted somewhere inside the logging module, accessing this map value that logging has to access this information. So we're just basically saying, hey, get this information from this map you've got stored in your module, and then put this together, and that's how we want our message to appear. So that's basically what that is. What this 8 represents is that basically no matter how long the level name is, no matter how many characters it contains, it's going to ensure that no matter how long the actual value is, there's going to be padding so that a certain amount of space is being used. In this case, 8 character blocks are going to be used when printing out the level name. So for example, info. It's going to say info, but because info is only 4 characters, it's going to add 4 spaces before the word to ensure that there is a total of 8 spaces being used by that level name, even if it's just empty spaces. And then these lines here are just fancy formatting on my part. I can add dashes here, I can add equal signs or colons. It could just be pure spaces or tabs. It could be whatever you want. I usually do this, and I'll explain why later because it actually helps me out with more advanced formatting. It's not necessarily something I would like to have printed on the screen most of the time. It just helps me break up the different variables so that when I do my own fancy formatting, it's easier to separate things out. But I'll go more into detail about that later because I'm going to show you something really cool you can do, and that's what this helps me out with. But for the sake of this example, it's at the very least going to make this a little less boring than the output from the first example. In this example, we're going to see a timestamp first, followed by the level name, which will be debug, info, warning, error, or critical, and they'll be all caps, followed by any space padding needed. Critical is the only one that's not going to get any padding because it's actually 8 characters long. That's why I chose that number, is because I want it to be in line with the longest uh, level name, which is critical. And then it's going to print out the message. And so I'm going to run it. And there you go. We've got our really cool timestamp. You can make the timestamps less detailed, so you can just have a date and then hours, minutes, and seconds, and you can get rid of the milliseconds here, or you can just get rid of the date entirely. You can change the way the date is formatted, so you can have month, day, year instead of year, month, day, or whatever, and so forth. So there's tons of ways to format this part here. So this is our level name right here. So we got debug, info, warning, error, and critical. And then we got the messages like usual. And then, these cool little lines here to make it a little bit more organized and spaced out. Particularly helpful when you've got a lot of messages printing. And so you want to try to keep things organized, especially if some lines tend to bleed over and go to the next line before the next login message is actually printed. But the basic config method can be used to do a lot more stuff. So for this example, the basic config method is almost the same. We're still using the same format string, we're still using the same level, and we're still using the same encoding, but now we have a keyword specifying file name. And this could be both relative or absolute paths. It'll write out to the file, and if it doesn't exist, then it will create it. So in this case, I'm going to write out to a file called log.out. So when I run it, we're not going to see any output. We'll see a couple of blank spaces from those print lines. But if I look at my directory, but as you can see at the bottom right here, we have a log.out file. So I'm going to open that, and there are messages right there. However, there will be times where we don't want to send messages just to one place, whether the screen or the file. Sometimes we want to send it to both. And in this example here, we can do just that, still using the basic config method. We just have to do things a little bit differently. So in this example, we still have our format, level, and encoding, but you may have noticed that we got rid of the file name keyword, and there's a reason for that. In order to set this up to send the logs to a screen as well as to a file, we have to specify 2 different handlers. The stream handler, which sends things to the screen, and the file handler, which will send things to the file. Basic config method will throw an error if we try to specify the file name keyword while also trying to establish a stream handler in the same method call. So instead of using the file name keyword, we're instead going to create a file handler where we can pass the name of the file directly into that object. So we create a list of handlers here and assign it to the handler's keyword, starting with the stream handler for the console, and then the file handler for the file. And then that's where we specify our file name, log2.out. And then it's going to be more of the same. We're going to log these messages, and we're going to see it print on the screen. But then we're also going to see a file get created called log2.out that will contain the messages there as well. So there's the messages printed on the screen. And then I'm going to open log2.out, and there are the messages there as well. Now, if we want to have a more advanced logging system for our programs, then we're going to have to write some code that's slightly more advanced than the basic config function. And one such method is to build the components manually. So after we import logging, I create a new logger with logging.getLogger. What this does is it returns a logging object that is associated with the name that we pass in. If that logger does not exist, it will create it. So I'm creating a logger with the name custom_logger, and I'm assigning it to the c_log. And then I set its level to debug so we can capture all of the messages. And I want this logger to be able to send messages to both the screen as well as a file. So I'm going to create 2 handlers, a stream handler and a file handler. And for the file handler, I give it the file name that I want it to send the logs to, log3.out. Then we specify our formatters. Now I want the formatters to be a bit different. I want the format for the messages sent to the screen to be pretty simplistic, relatively speaking. I want it to still have the bare minimum information, the time, the level of the log, and then the message. But for the format for the file logs, I want it to also specify the name of the logger. And while in this example that's pretty simplistic, that may not seem like a very interesting thing to do, there are cases where you might have different loggers logging different things, whether it's like multiple different components. Maybe you've got a bunch of subprocesses going on and they all have their own custom log messages. So you want to separate them out by their log names. There's tons of reasons why you would specify the name inside your format. Once we've created our formatters, we then assign the formatters to our handlers. So we use the .setFormatter method for both our handlers to assign them the proper formatter that they're going to use. The console formatter goes to sh and the file formatter goes to fh. Then we add both these handlers to our logger object, which we are referencing using the clog variable name. And then as with all the other examples, we log the same messages, but this time, instead of using logging.info or logging.warning or etc., we instead say clog.info to log the messages to our new custom logger here. So when I run this, we still got our messages here, and then we access our log file we generated. And as you can see, we've got our timestamp, we've got the logger name, which is custom logger as specified here, and then the message's level name, and then the message itself. Now that was quite a bit of code just to set up a logger to send logs to the screen in a file. And some programs may have even more complex setups. Fortunately, the next two configuration methods I'm going to show you can make it a bit easier to set up. So up next is a method that involves using a configuration file format most commonly seen in the unix.conf files and the windows.ini files. And that method is the fileConfig method. But unlike the basicConfig method, this method is stored somewhere else. So after we import the logging module, we then add another import line here from logging.config import fileConfig. This will allow us to use the fileConfig method directly. And when we call the method, all we have to do is pass in a string containing the file path to the configuration file we want to load. And that file will contain all the information needed to configure our logging. So for this example, I have a logging underscore conf underscore example.conf file, which I have open right here. So first we have to establish names for all of our components, our loggers, our handlers, and our formatters. For loggers, we always have to specify root. It won't let you leave out root, so you have to specify that. But then we can specify our actual custom logger, which in here, as you see, I just named it custom underscore logger again. For handlers, I specify the S handler for our stream handler and the F handler for our file handler. And then for formatters, I just specify a single formatter. We're not going to do anything crazy like last example. So we're just going to have a single format for our messages. Now we can actually add the details to these components. And the way we do this we'll start with loggers since that's up next, is when we want to specify the settings for root and custom logger, we have to first say logger, followed by an underscore, followed by the name of our key. So logger underscore root for the root logger. And then we can specify the information under it. And the keywords we use here are the same keywords we would use if we were establishing our loggers using the previous methods. So we got our level for root, and we're going to set it to debug. For handlers, we do have to specify handlers followed by an equal sign, but we can leave it empty. And this is important to do when you're specifying your own custom logger like this, because if we try to specify a handler here, it will actually cause duplicate information to be logged onto the screen and the file. So you'll see every message happen twice. So you do have to specify it for the sake of the configuration file, but you can leave it blank. Then we have logger custom logger. So logger underscore to specify we're configuring another logger, followed by the name, which is custom underscore logger as specified up here. We're also saying that the level is debug. And then for our handlers, we specify the two handlers that we defined up here, comma separated, of course. And then we have qual name. Now, qual name is how we're going to refer to our logger in the code. So as you can see here, I call get logger and I specify C underscore logger, not custom underscore logger, but C underscore logger. Now we've got our handlers. So we've got handler S handler and handler F handler. S handler is of course a stream handler. We specify debug level. We assign it a formatter, custom formatter, which is down here, and then args. arg specifies various arguments for the handler. I don't know much details about them specifically. I just know that in the very basic setup that you need in order for a stream handler to work is you need to specify sys.std out followed by a comma because this is supposed to be a tuple. And then we have file handler, which for the most part has the same thing as the S handler. We have file handler for the class, debug for the level, and then formatter is of course pointing to this formatter here. And then for args, we specify two things, the file name and the write mode. Now the write mode could be typically one of two, either W or A. Now what W stands for is write. What write will do is that if the file doesn't exist, it will create the file and start writing the logs to that file. If the log file did exist, then it's going to overwrite it, clearing the log files from the last time it ran and writing the new messages to it. The other mode, A, for append, will keep the existing log data if the log file existed and simply write the new data at the end of it. So you will have log information from the current run as well as previous runs. And then of course for formatter, we've got formatter underscore and then the name of our formatter, which is custom formatter. And as you can see right here, you don't really need to encase it in quotes. You just write it out as one line. The fileConfig method will understand what's being done here. So you don't have to encase it in quotes or anything like that. So we call fileConfig method, we pass in the file with all those settings into here, and then we get our logger, which again, we use the word clogger because that is the qual name for our custom logger. We assign it to a clog variable, and then like before, we use that clog variable to access the logger and call these methods to create these messages. So when I run this example, we've got all our messages here, and then I open up log4, and there are all the messages that were written to the file. So when you have a program that's going to have a very complex logging setup, but you don't want to have a lot of Python code to build that setup, this is a pretty good way to keep your settings and everything separate. So you can just define all your settings in here and keep it in a separate file and just say, hey, load up these settings from this file here, and then you don't have to have that messy Python code. Another way to configure our logging is through the use of dictionaries with the dictionary-config method. That can also be found in the logging.config module. Now on its own, as you can see, it could be just as messy, if not worse, than just building the components manually. However, if you were to pair this with a Python module that can parse YAML files, then you can just have all the settings and information stored in a YAML file and then use that module to read in the data, because those modules typically return all the data in the form of a dictionary. And another cool thing is that we don't have to specify the root logger when we use the dictionary config method. Unlike the file config method, we can just specify our custom logger and that's it. So there's a lot of stuff in here. A lot of it is very similar to the configuration file in the previous example, but we do have some extra stuff we have to add, and we do have some extra items here. I'm not quite sure what the version number specifies, and I'm not sure if that's entirely needed every single time, but I do include it. The second one here, disable existing loggers. It will disable any loggers that are built when the logging module is imported, so we don't have to worry about accidentally calling those. So at the top here, I've got my formatters, and this keyword here, custom, is how we refer to the formatter in the settings down here. So when we go down to handlers and you see the formatter, we refer to the key here, which is custom, to assign this format to this handler. And we can, of course, have multiple formatters. We would just have to have multiple keys here to have key terms to reference in the handlers. And then this keyword is mapped to another dictionary value. And inside this dictionary value, there's typically only one keyword. I've never really seen additional keywords put in here, but there could be others. But for the most part, I've only ever seen this one, and that's format, which is where you specify your format string. Then we've got handlers, and like the formatters, you specify the key name for your handler. I have console and file. As you can see, you can recognize a lot of the keys are the settings that we would typically specify when we create a handler, the class, the level, our formatter. And then down here, we can specify our file name as well as our mode, which again, I've set to write. And when we're specifying the classes this way, we do have to specify logging.streamHandler and logging.fileHandler, simply because that's how the logging module needs to see it when we set it up in this manner. And then down here, we've got our loggers. We've got the custom logger. We specify level debug. And we specify our handlers, which we can put as a list with console and file. So this will allow it to write to both file and the console screen when we send messages to this logger. Now, I like this particular type of configuration the most. It's actually the easiest to configure and the easiest for an end user to configure when you pair it with YAML parsing. Now, one thing you've most likely noticed and are now probably wondering from all our previous examples is why do we have to specify a level for the handlers as well as the loggers? Our handlers can by default be set to debug so that it includes everything. However, we can provide control with the custom logger to say, hey, I want this to be set to info by default. But if something weird happens, you can go back here and just say, all right, let's change this from info to debug so that we can capture everything. So with the handlers, we can set it to debug and just leave it like that. And then that way, no matter what, it will capture everything when necessary, but it will only log what the logger can capture. So if we specify a higher level with the custom logger, these handlers will not see what this custom logger is not configured to see. If this was set to warning, then any debug and info messages that were sent through this would not be sent to the handler, so the handlers won't see any of that. That's just a way to provide some decent amount of control. And you can provide specifications up here as well. Like for console, maybe we don't want to see all those crazy debug messages. Maybe we just want debugging messages to go to the file. So we can just say only allow info and up to be written to the screen, but we can have everything written to the file. It just allows you to have that fine-tuned control of what gets written where and how much of it gets written. So that's why you specify the level for all of these pieces. And then down here, we call our dictionary config method. We pass in the variable named log settings, which contains our dictionary up here. And then we get our logger, custom logger, which is the key name we've defined here. And then we write our messages like normal, and they'll be written to log5.out as well as being printed on the screen. So here are our messages. And then I open up log5.out, and there are messages written to the file as well. Now that's just normal configuration stuff for logging, but there's some more advanced things we can do as well, like creating our own custom subclasses for certain logging components. For this video, I'm only going to focus on one particular component because in my opinion, it is the easiest and probably the most common one to make a subclass for, the formatter class. A common reason for building our own formatter subclass is to add a bit of color to the messages that get printed out on the screen, but we can also use it to directly control the message formatting, or maybe even add additional information on top of whatever formatting we specify. So I've got 3 different examples to show off a custom formatter class. For this first one, it's pretty basic. So in this example, I just have a formatter that is just going to control the coloring of our messages based on the log level. The first thing I do is I specify my colors. Now you can do this a number of different ways. There are libraries out there that allow you to get the colors you want by their name, or if you don't want to import extra libraries into your logging code, then you can just specify color codes yourself inside your own code. And that's what I'm doing here. I use color codes that you would use in Bear shell script. They work here in Python as well. I'm not going to go into too much detail about them. If you want to learn more about these codes here, you can Google shell text coloring or something like that to learn more of how this works and everything. But basically, these codes here correlate to these colors. NC here is basically a reset code. It will change it back to its default formatting. And then we have our custom class here, color formatter. It of course inherits from the formatter class in the logging module. There are 2 methods that we have to overwrite for this to work. The first is of course the init method, and the second one is the format method. So the first thing we do with init is that it takes in 1 parameter. You can have it take in a parameter, but in other cases you can also have it just not take in anything. But for this example, we're going to take in 1 parameter here, and that's going to be our format string. And then the first thing we do under init is we call the supers init. Then we assign the value of this parameter to self.fmt. And then we have to create a dictionary that maps the logging levels to the way we want to format them. So for logging debug, it's the default format. I don't change it or anything like that. It's just going to have the normal colors. For info, we're going to change our entire message to blue. For warning, we're going to change it to yellow. For error, we're going to change it to orange. And for critical, we're going to change it to red. And as you can see at the end of each of these, we reset the formatting. And then down here, the def format, this is basically all you need to have format apply your formatting to your messages. As long as you have these 3 lines, it will work. And this format method is not anything you have to call specifically yourself. It is called internally whenever you log a message with your logger. And then down here, we set up our logger as usual. The only difference is that instead of using a normal formatter class, we use our custom formatter class, and then we assign that formatter to our stream handler here. And if you're creating formatters to add color to your messages and stuff, then it's recommended to only apply those to your stream handlers, because if you try to apply it to other handlers, it will make your messages look weird because it's just going to print out those escape codes. Or if you're using external coloring libraries, it might cause some other weird things to happen. So it's really only recommended to use this for your stream handler. So when I run it, our debug message stays the same, and then our other messages, they change to their respective colors based on what level we assign to them. But we can be a little bit more creative with how we format our stuff. We don't have to just change the entire line to a specific color. We can break it up into multiple colors. And if you recall earlier in the video, I said I like to put the pipe characters in my own formatting strings. And this is actually going to be the reason why. It's because it allows me to break up the message into its different components so I can control the color of those different components and then put them back together for the actual message. So I have our color formatter again, and I have the same colors as before. And it's pretty much the same except for a couple of things. One, I don't actually store FMT within the object itself. There's no self.fmt, it's just FMT. And the reason I did that was to show you that even though a lot of examples out there will show them assigning self.fmt to this, you don't actually need to do that unless you need to access self.fmt down here, which normally you don't. Normally you're just accessing the formats table here. So you don't have to store FMT in the object permanently. So I just prepare it for what it needs to do within the init, and then after that, it just goes away because the information is still going to be inside this table here, which we do store in self. So I take the format and I break it apart using the split function and split it by the pipeline characters. And that's why I like to use those pipe characters, is so I can split it up into the different components. And then I reassemble the format string down here with the different components while also applying the colors that I need. So the very first item, which usually should be the timestamp, I always have my timestamp as the first item in my format string. I apply it the color green. So all my timestamps will be green. And then this is where it's going to be different for the logging level. I apply the different colors to the log level itself. So only the logging level text will be the different colors. Orange, yellow, blue, red, whatever. And then the messages themselves will just be the default color for your terminal text. Aside from that, everything else in this class is the same. And the setup is still the same. We apply these messages here and everything, but you may have noticed that I don't have spaces in between them anymore. I leave the spaces out because I add them here. The only thing that's going to really generate spaces from the string itself is the 8s here to ensure that we have padding with the level name. So then when I run this, we got green text for the timestamps, different colored text for all the logging levels, and then just the default text color for the messages. Makes it a little bit more nice and pretty. This is how I typically format my logging messages. I usually only have these 3 components for my stream handler: the timestamp, the level, and then the message itself. The timestamps I always just color green, and the only thing else that gets colored are the logging levels. The text from the messages is usually just the default color of the terminal. And then this final example is pretty much the same as the last example. It's formatting the messages with the colors the exact same way. The only difference is we don't take in a parameter here for init. We define the message inside of it right off the bat. And I have it broken up as a tuple so that it's not just a string. We don't have to do any splits or anything like that. So we can just immediately reference it by index numbers in our messages here. And it pretty much just behaves the exact same way as the previous example. I wouldn't typically do it this way, but you can if you want, especially if you just want your logging messages to be the same no matter what. But when we run it, it comes out exactly the same. The only thing different here is that we can't specify our format string inside this object call here. It's just set by default inside the init. And that's about it for logging in Python. So I hope you've enjoyed this video and found it helpful, and if you did, then please hit the like button and leave a comment below to let me know what you think. And if you want to see more, head on over to Wayfair Coding Academy channel to check out my other content. And while you're there, subscribe to the channel to stay up to date on new stuff as it comes out. Thanks for watching, and I'll see you all next time.